Next section we have to talk about is set builder and interval notation. These are different ways of writing our domain and range and all that good stuff. So just some reminders about some algebraic notation. We have like our less than symbol, greater than, less than or equal to, all that kind of good stuff. Here's some good reference of like word or phrases where those are used. This fancy looking R is our all real numbers shortcut there, so we can use that instead of writing all real numbers. For these examples here, let's kind of look at this situation here with this number line. We've got everything that is actually x is less than 2. So let's see how this works. With set builder notation, you basically just say that inequality that x is less than 2, but you kind of get a little bit fancier sometimes. So you put these like little fancy brackets, and we put an x. That lets us know that, okay, x is what we're working with. Most likely it's a domain because domain is x's. If it was range, we would use a y there. Okay. This little line here is read that it means such that. So it's like, hey, we have a domain that is made up of x's such that x is less than 2. So it just kind of gets a little bit fancier. Yes, I'd like for us to just be able to just write the inequality, but when we do set builder, this is what you get. Interval notation is usually a little bit faster, easier once you get used to how it works, but it's good to be able to know both systems so that you can read something. If this is presented to you, you should be able to read anything in any format. Interval notation basically just needs the start and the end, and you use parentheses or brackets depending on if you use it or don't use it. In this example, we're using basically all these negative numbers. It goes on forever. We use all the negative numbers and then everything up to 2. So we would say we use all the negative numbers. We go from lowest to highest, so negative infinity up until 2. Now, both of these use parentheses because you'll always use parentheses on the infinity side. With this 2, though, we use parentheses because we don't include 2. If this was a filled-in circle, then I would use a bracket around this 2. You'll see some of that in our other examples. So in my opinion, I prefer interval notation. There are times you can't use this and you have to use like a set builder or inequality notation, but let's explore some examples. Most of these here are going to be continuous graphs, so in the beginning, so we get used to this. So let's think about this here. We're going to do domain and range, and we're going to do it in set builder and interval notation, so let's see how it works. First up, let's just think about domain as all our x's. What x's do we use? Well, it keeps going wider both ways. It keeps going, yes, up, but it's also getting wider to the left, wider to the right. I can't think of any x's we don't use. Many of these first examples will have this kind of situation. Our domain is x. X is an element of the real number. Sorry if I forgot to talk about that. This little fancy e is an element of. So we're basically saying, hey, we have an x such that x is an element of all the real numbers. All the real numbers work. Cool. The range, we'll come back to here in just a second. I'm going to scroll down here to the domain. Another way to do your domain would be negative infinity until infinity. Parentheses always on infinity. This is the other way of saying all real numbers. So why is the range this? Let's go back to that. So our ranges are y values. The lowest is -3. I don't go below -3. I don't get to -4. There's no graph down here. So we get to -3 and above. So we'd say range is y, because now we're talking about y values, such that y is greater than or equal to -3. We do hit that point, so we would do the equal to. In interval notation, we would say, okay, the lowest is -3. Notice there's a bracket because we hit that point. And then, okay, what's the highest point? Well, -3 is the lowest, and then it keeps going up, so the highest is infinity. So you can have a mix and match here, one bracket, one parentheses, or you can have both parentheses if you're dealing with infinity or values you don't use. Let's try it again. You'll kind of notice a lot of these, the domain is pretty basic. It's, again, element of the real numbers here because it keeps going left, it keeps going right. But what about our range? Well, let's see, the lowest, well, it keeps getting lower. We keep using all these negative numbers as it keeps going down, but it doesn't keep going up. It stops here, but it's not at -2. Remember, we're talking about y values. The highest point here is 0. So we'd say y such that y is less than or equal to 0. In interval notation, again, domain would be negative infinity to infinity. For our range, we'd say, okay, yeah, all the negative numbers, I want to use all the negative numbers until I get to 0. And I hit that point, so I use a bracket. You could write these in a different order, like 0, negative infinity. It's just kind of talking backwards and not always accepted by everybody. So you should write it lowest to highest. I'm going to encourage you guys to maybe pause the video and try these yourselves. And then you can unpause it and just check and see what we get here. In this case, once again, our domain is all real numbers, element of all real numbers, negative infinity to infinity. And actually, very similar to the other one, the range goes down forever, everything up until 3. This guy here, you can say that 2 ways. Everything less than or equal to 3, or all the negative numbers up until 3, like that. Once again, This is why lines are so boring. Like we never did much with domain and range with lines because like it's so boring. It's all real numbers, negative infinity to infinity for everything because it keeps going up, keeps going down, keeps going left, keeps going right. Nothing that interesting. But what about these guys that are not continuous here? So we have some discontinuous intervals. Let's see. Here's where I kind of work left to right. So my domain is like, okay, well, it keeps going to the left. So all the negative numbers until this point at -1. All right. And then it starts here again. It kind of skips over. And when x is 0, I start again and I keep going this way to infinity. So it would be something like this. Everything less than -1 and everything greater than or equal to 0. Again, we do that separator notation. We say x such that x is less than -1 or x is greater than or equal to 0. For our interval notation, you write it this way. All the negative numbers until -1, notice parentheses, we don't include it, it's an open circle. Then I pick back up at 0. I start at 0 right here, an x value of 0. And again, that's a bracket because we hit that point. It's a closed circle to infinity. Now what about that range? Okay, lowest. So we go to the y-axis here. Lowest, well, it keeps going down to negative infinity until I get to -1. So actually our y is less than -1. Or let's see, y can be greater than 2 because yes, we're at this point here. It's a y value of 2. So 2 and bigger keeps going up. So y can be greater than or equal to 2. An interval notation would be negative infinity until -1. And then, I'm sorry if I didn't mention this before, there's a union. It just means we have more than one interval here, so we're doing a union. So union with starts back up at 2, notice that bracket on the 2, and it goes to infinity. Feel free to pause and try this next one out, or we can go through here together. In Set Builder would be everything less than -1. So notice here's everything negative. We use all the negative numbers until -1, very similar to this guy here, okay? And then everything bigger than +1. So we don't use any numbers here until we get to this point, which is at an x value of 1. Okay? In interval notation, we would have said negative infinity until -1. Again, parentheses there because it's an open circle. And then +1 has a bracket because we use it. The little u because we have more than one thing here. So how about that range? Okay, y is an element of the real numbers. Wait, I thought there were some places where there was a hole. Well, this graph keeps going down, okay, keeps going down, and over here keeps going up. So you're right, this y value here of 1 is not used here, but a y value of 1 is used somewhere else. So yeah, maybe it's not used there, but since we use a value somewhere along the graph, we actually use everything. So we use all the y values here, all the y values there, so we actually use all of the y values. So we could say negative infinity to infinity, or y is an element of the real numbers. Hope that gives you some ideas and brings some questions to class.